Hi everyone. Today I'm going to go over one of these revision papers. This can be found on the website. It's quite a good website actually. It's bland.in, and this is basically it's written out there, bland.in, and this is the transformations worksheet from this website. And it's basically past exam paper questions on transformations. What I'm going to do is basically just go through all of the questions on this paper. Hopefully you'll be able to see that right here. And here we go. Right. The first question says, here are some patterns of circles. The question asks us to shade 2 more circles to give the pattern symmetry in the mirror line. So you have your mirror line right down the center. You can see there's a shaded circle here but not one there, so I'm going to shade that in. So that helps. You can see there's a shaded circle here but not there, so I'm going to shade that in. And there we go. Done. Symmetry. Right. Shade 2 more circles to give this pattern symmetry in both mirror lines. So I've got to shade that circle in so that it's symmetrical about this one. Got to shade that circle in so that it's symmetrical about this one. Alright, here. Shade 4 more circles to give this pattern symmetry in the mirror line. Ooh, interesting. So, okay, so for it to be symmetrical diagonally, I have to be able to fold it on itself. So I'll shade this one in here. Imagine this is my mirror line. So that's symmetrical. That 1, 2.5. That one, that's 2 circles done. Okay, and I can choose any 2, I guess. Any 2. I'll go for the middle 2. Yeah. And there we go. And symmetrical about that line. Yeah. Okay, so here in this question, that and that, those 2 circles had to be filled in, and the other 2 circles, as long as there's a choice of these 2, or you could do these 2 or those 2 or those 2. Okay. The next question is an enlargement question. It says the shape ABCD is drawn on a grid, and that's a rectangle ABCD over there. Congratulations, yeah. Enlarge ABCD by the scale factor 3. Now, here in an enlargement question, they've given us the scale factor, which is 3. So I'm going to multiply all the sides by 3, and that's going to give me my new shape. But because there is no center of enlargement, that shape can be anywhere. So that's 2 times 3 is 6, and 3 times 3 is 9. Okay, so I'm gonna have a 6 by 9 rectangle. 1, 2, 3. Okay, wait, let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9. That was a mess up. Very bad. The line's not straight. Erase. Okay. It's like a last minute revision video. So you can just download this worksheet from bland.in, which is a very, very good website. And I believe he's a tutor as well, Mr. Bland. But he's got some very good resources. And he's benefited plenty of people. Yeah. Plenty. Right. 3, 4, 5, 6, 7, 8, and 9. Just finishing off my rectangle here. So it's 9 by 6. Just make this line a bit more thicker. So you can see that. Can you see that? Yes, you should be able to see that. So that's 1, 2, 3, 4, 5, 6. That's 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. How many times bigger is the area of the enlarged shape than the area of ABCD? Now, there's two ways you can do this. You can actually work out the area by either counting the squares or working out the area of ABCD. So you can say area of ABCD is equal to 2 times 3, which is 6 square units. And area of the enlarged shape, that would be 6 times 9, which is 54 square units. Right. So how many times larger is it? Well, we do 54 divided by 6, and it's 9 times larger. Now there's a quicker way to do this, which is, oops, let me just push that up so you can see that. You missed all of that. There's a quicker way to do this, and that is, you see the scale factor, which they mention. It's a one-dimensional scale factor. That means it's the scale factor of the length. Okay, so if the scale factor of the length is 3, it's given in the question. To find the scale factor of the area, you have to take your scale factor length and you have to square it. So that is 3 squared, which is also 9, which is a quicker way. And if it was scale factor volume, you take your scale factor length and you cube it, and that gives you the scale factor volume of the volume, I should say. Anyway, we'll move on to question number 3. Question number 3. The number 71. Let me put it. There we go. Here we go. Thank you. The number 71 is shaded on the grid. What fraction of the grid is shaded? Okay, so what we need to do is we need to find out how many numbers on the grid. 1, 2, 3, 4, 5, 6. How many squares? There's 6 by 1, 2, 3, 4, 5. So they're 30. 6, 12, 18, 24, 30. There's 30, so I know my denominator is 30. And then I was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 out of 30, both of them come in the 6 times table, so I'm going to divide by 6, and 12 divided by 6 is 2, and 30 divided by 6 is 5. 2/5 of the shape is shaded. Alright, shading. And the letter S is shaded on this grid, and draw the reflection of the letter S in the mirror line. So I'm going to shade this in. Just going to quickly... My shading skills are not very good today. Where's that ruler? Not very good. My art teacher would not be too proud of this. Shade it in, 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 shade it in. Today, goodness, hurry up. Come on. Shaded. There we go. 52. It looks like a 52, but it's a shape, S shape, which is reflected. There we go. Next one. Quickly. The number 8 is drawn. Can you see that? Excellent. Write down the order of rotational symmetry. Right, the order of rotational symmetry. For this, I need to get myself a piece of tracing paper. Hold on. There we go. I've got a sheet of tracing paper. So what I'm going to do is I'm going to mark an arrow facing the top. I'm going to just quickly trace this shape over. There we go. Not the best art skills today, but anyway. And I'm going to place my pencil right at the top, in the middle. And I'm going to rotate this shape a whole turn and see 360 degrees, a full turn, and see how many times it's going to be the same shape, yeah? So it's not, nope. There's one, nope. Two. So it is the same shape exactly 2 times, so the order of rotational symmetry is 2. Thank you very much. A shape with order of rotational symmetry 2. That's how you find the order of rotational symmetry. If the order of rotational symmetry is 1, that means the shape has no rotational symmetry. Okay, we're coming back, okay, to this one, which is triangle T has been drawn on the grid. Rotate T 90 degrees clockwise about the point 10. Pause again. Here I've got another sheet of tracing paper over there. So the triangle T has been drawn on the grid. Very good. Rotate it 90 degrees about the point 10. 10 has been already marked for us. So I'm going to place this on here. The tracing paper. Sketch in the triangle. Really quickly. Place my pencil on the center of rotation. And it says 90 degrees clockwise. Clockwise is this way. So 90 degrees is a quarter of a turn. And there we go. I'm going to stop there. Just quickly, slowly. You can see that's 1 point. And that's 1 point. And that's the third one. Move that away. Get my ruler, which broke unfortunately whilst making this video. And connect the 3 points. Draw my shape. There we go. Label the new triangle A. Done that. A. And A is done. That's how you rotate. Alright, next question. Quick. Oh, look. Describe it fully. I like the describing the transformation questions. Okay. So, describe fully the single transformation which maps shape A onto shape B with the unfortunately broken ruler. You see, this point here on shape A corresponds to that point there on shape B. So I'm going to draw a line through them. Okay, now that point there on shape A corresponds to that point there on shape B. So again, do the same. Draw a line. And then that line and that point there on shape B corresponds to that point there again, shape A. And draw a line. And then that point there on shape A corresponds to that point there on shape B. And we draw a line. And I can see all of them kind of meet over here at this point, which is 1, 0. Okay, so that is my center of enlargement. That's how you find the center of enlargement. So I've been asked to describe this. So I have to mention a few things. What kind of transformation is this? It is an enlargement. So enlarge. It says that maps shape A onto shape B. So I have to work out the scale factor from A to B, not B to A. This is, you got to be very careful about this bit. So I can see that's 1, 2, 1, 2. That's 1. This one, this side is 4, that side is 4, and that side is 2. So I know that I have to double it. So enlarge shape A by the scale factor is 2 because every side is doubled. Scale factor 2 from the center of enlargement one zero. Right, let's move on. Can you see that? You can see that. Excellent. Next. Right. Oh. The next question here, which is question 6. Triangle P and triangle Q are drawn on the grid. Describe fully the single transformation. Now, when you got a transformation like this, I need some tracing paper, some brand new tracing paper. You can see the shape is quite clearly rotated. So, what we need to do is find the center of rotation. Now, there is a way of finding the center of rotation, which is there's one way, which is to guess. There is another way, which is, I'll show you how, but it is a bit slightly complicated. So I know this point over here on triangle Q corresponds to this point there on triangle P. I'm going to join them up. Okay, and then I know this point there on triangle Q corresponds to that point there on triangle P. Join them up. Yay. Okay, and then what I'm supposed to do is where's the other ruler? This one's a better one, yes. Okay, so I'm gonna measure the midpoints. In this case, both of them are meeting at the origin, so it's quite clearly the origin, but normally we're supposed to measure the midpoints, and then at the midpoints we are supposed to draw perpendicular lines. So something like this. And the midpoint for this is also happens to be there. And to draw a perpendicular line, can you see this? Where the two perpendicular lines meet is your center of rotation. Anyway, it says describe fully the transformation which maps triangle P onto triangle Q. So I'm going to trace P. I'm going to go to Q. Now I found the center of rotation, so I'm going to place it on my pencil on there. I can go either anti-clockwise, so that's 90 and 180, or I can go clockwise, 90 and 180. 180 degrees is half a turn, so whether it's anti-clockwise or clockwise, it won't make a difference. But at any other turn, it would, except for a 360, which wouldn't really rotate the shape. But anyway, rotate shape P by 180 degrees. If you want, you can write anti-clockwise or clockwise. You can say anti-clockwise. But only a 180 degree turn, both anti-clockwise or clockwise, is going to be the same. If it was a 90 degree one, you have to be very careful. From the center of rotation 0, 0. It's like a Man United score at home at the moment. Translate triangle P by the vector 3, 0. 3, 0. Okay, there's two ways of doing this. One is you trace the shape on there. Okay, now the vector 3, 0, the way column vectors work, these are not coordinates. Coordinates give you the location of a point. This is a column vector. It tells you which way you are going to move. So, if the let me just say this. So the top number tells you which direction you have, how many places you have to move in the horizontal or the x direction. And if it is positive, you go right. If it's negative, you go left. If it's 0, you do not move. And the second number, the one at the bottom, this is not a pair of coordinates or a fraction. This tells you how many places you move in the y direction, or the vertical, not the horizontal, the vertical direction. And if it is positive, you go up. If it is negative, you go down. And if it's 0, you do not move. So 3, 0 basically is telling me to go 3 right, and I do not move up or down. So that's 1, 2, and 3. And then I just quickly place my points. Tracing paper is so useful. Makes life so easy. Oh, maybe. Big tip. In the exam, do not do what I just did. What did I just do? I drew with a pen. Do not draw with a pen. Draw with a pencil. Label this new triangle. Oh, this is a pencil. There we go. Sorry, I drew you with a pen. Right, next question. Rotate. 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 I need another piece of tracing paper. This one ripped quite bad. Okay. Can you see that? Number 7, rotate the shaded shape 180 degrees clockwise about the point O. So I just quickly go up the shape. Place it on O. 180 degrees, half a turn. Whoa. Let me just double check. I have not gone over the shape properly. My pencil is dying. So was my phone's battery. There. 90, 180. So, as I did before, just quickly go over there. Arc shape. 1, 2, 1, 2. 1, 2, 3. Alright. Now, I've just gone over the rough shape. I'm not going to leave it like that. I want all my marks, so I'm going to actually draw it nice and neatly. I'm going to go over it with a pencil. Okay, and a ruler. There we go, nice and neat. Alright, that's done. Describe the single transformation that maps shape A onto shape B. So we're going from A to B here, not B to A. Although B to A would be fun as well. Now here, it's not a rotation, it's a translation. A translation is either a horizontal or a vertical or a diagonal movement. In this case, it is a diagonal. And remember when I said let's find out what the column vector is. So I'm going to choose this point here. That point on A corresponds to that point on B. So I've gone 1, 2, 3 places to the right. So that's my first number. And I've gone 1 place down. So that's the second number, 3 minus 1. So translate, because it's a translation. Translate shape A by the column vector 3 minus 1. There. That's done. Next. Question number 8. Question number 8 is triangle A has been drawn on the grid. Why scale factor 3 every single time? This time we need to enlarge the shape by scale factor 3. That's 2 by 1. So I'm going to go 6 by 3. There's no center of enlargement, so I can draw anywhere. 1, 2, 3, 4, 5, 6. It's like Braveheart, you have the freedom to draw anywhere. Okay. Do we call this anything? No. This is a nameless triangle. Oh well. Triangle Q has been drawn on a grid. Next question. On the grid, rotate triangle Q 90 degrees clockwise. I need a tracing paper clockwise. Running out of tracing paper. This one's also ripped badly. Okay. 90 degrees clockwise, center O. Okay, so we first trace over that. This pencil is like dying. Center O is there, so I place my pencil on top and I hold it. I just rotate it 90 degrees clockwise. Clockwise is this way. 90 degrees is a quarter of a turn, so I rotate it 90, and I can see quickly should be somewhere there. So marker point, and marker point. Yep. Okay, move. Take the good ruler. Bad one, plenty of airtime. It's actually really good. Both of them are good. The other one just doesn't look so good because of the broken bit, but it's actually quite good. I like that ruler. Right, and does it ask you to name shape? No, this is also another nameless shape. Yeah, did you see that? I hope you did. This video is going on. That's 26 minutes. Woohoo! We have 1, 2, 3. A few more pages. I'll just quickly speed on with this. Okay. It says rotate triangle Q 180 degrees about the point minus 1, 1. So I'm just gonna quickly trace this. Wow. Okay. Rotate triangle Q 8 degrees. The point is minus 1, 1, which is that one. Just place my pencil over there. Rotate 180 degrees clockwise, anti-clockwise doesn't make a difference. 1 and 2. Right. This is the slightly tricky part, so slowly point there, and point there. Alright. And I'll quickly join it up. Oops. I'll join it up. Join it up. There we go. That's the shape. This time we have to label it triangle A, so don't forget to do that. Alright. Now translate triangle Q by the column vector. The good thing is, with the tracing paper, it's easy to translate shape Q. 6. I mean, 6 is positive, so you're going right. That's in the X direction. And this is in the Y direction. So positive, negative, 0. Okay, so that means that you're going 6 to the right and 1 down. Wow. So I'm going to go 1, 2, 3, 4, 5, 6 to the right, and 1 down. 1 down. So there, 1, 2, and there, 3. 6 to the right and 1 down. Let me call this B. There we go. That's done. Right. How much more can I do? I can quickly 1, 2. Only have a few more. I'm gonna speed through these. Here, finally, a reflection question. When you are reflecting into a diagonal line, there's 3 ways you can do it. One is use a mirror. I don't have a mirror right now, so I'm not gonna use it. So I can either count diagonally into the mirror line, which is my favorite way. But there's a second way, which is you count into the mirror line this way, horizontally, and then go up vertically. So you choose the 3 points, and I'll show you both ways. So both ways, not both way. The first one is diagonally, so I go half a square into the mirror line and I'll go half a square back, so I mark that point there. Here I go 1, 2 squares into the mirror line, so I go 1, 2 squares back over there. And here this way I go 1, 2, 3 to the mirror line, so I go 1, 2, 3 over there, and those are the 3 points. Now the other way, which was the horizontal vertical one, so I go into the mirror line horizontally, 1 square to the left, and then I'll go 1 up. From this I'll go 1, 2, 3, 4 to the left, and then 1, 2, 3, 4 up. And from here I'll go 1, 2, 3, 4, 5, 6 left, and then 1, 2, 3, 4, 5, 6 up. You end up at the same points. This triangle has to be called C. Transformations are so much fun. Easy marks as well, if you know what you're doing. But you have to read the question very, very carefully. Very carefully. Reflect shape A in the x-axis. Now this is, sorry, it says reflect shape in the y-axis. I was just telling you about reading the question. Didn't read the question myself. So that's the y-axis. If I was to reflect, again, you can use a mirror line or count into the mirror line. This time it's a vertical mirror line, so I'll count into it horizontally. 1 square, 1 square, 1 square, 1 square, 1, 2, 3, 1, 2, 3. There we go. That point is also 1, 2, 3, 1, 2, 3. 1, 2, 1, 2, 1, 2, 3, 1, 2, 3. There we go. Now we'll quickly draw this line, obviously. That's that now. Describe fully the single transformation which takes shape A onto shape B. It is a rotational, actually. This point corresponds to this point, so let's join it up. Does it? Does it? Does it? Please, does it? Okay, let's find another point which corresponds. This point here. Let me rub that off. This point here corresponds to